Okay, in this video, I'm going to be covering a very important topic in mathematics that is applied in a lot of machine learning algorithms. Okay, I think these are some of the basic things that you should know in machine learning. One of the important concept that is frequently being asked is what is Euclidean distance? Okay. So Euclidean distance obviously is to measure the distance between the two, points in a Cartesian coordinate. Okay, and you must have studied this from your, high school mathematics. The Pythagorean theorem. So if you have, let's say, a graph, okay, where you have one point and there's another point, and we call it with the coordinate of x1, y1. And the other one is x2, y2. The distance between the 2 points can be evaluated using a Pythagorean theorem, which can be plotted in a right angle triangle, and the value of the d is going to be the square root of x2 minus x1 the whole square plus y2 minus y1 the whole square, and the square root of that. Okay, that's the distance, and that's on a two-dimensional coordinate, correct? So that's that's basically, again, one of the simplest way to figure out, like, but it can be also done in a let's say in a one dimension. So in one dimension, the d of let's say I'm gonna be using a term called p and q, which is basically nothing but an absolute value of p minus q, right? But if you are looking at, let's say, in a two-dimensional format, right, that value of d of p and q can change to p1 minus q1 the whole square, p2 minus q2 the whole square. Okay, so that in a two-dimensional format, but this can also be different if you're looking at it at a higher dimension. Let's say if in a higher dimension, like in a multi-dimensional format, the distance between the p and q can be written as p1 minus q1 the whole square, p2 minus q2 the whole square, right, plus it can go up to pn minus qn the whole square, right? So in multi-dimensional format, the calculation can be much more difficult and computationally intensive. So I don't want to plot this in a graph, but if you look at it from a three-dimensional standpoint, the coordinates between in the p and the q will have p1, q1 value, and then the p2 q2 and let's say, or if you look at p1, so so let's say this is the one dimension, this is the two dimension, this is the third dimension, so it'll be p1, p2 and p3, and this one is q1, q2 and q3, right? And that dimension can keep changing. Let's say in an n dimension format, the value of the p is can be defined as or the coordinates of the value of the p can be defined as p1, p2, p3 till pn, and the q will be q1, q2, q3. Sorry, I'm just writing wrong. Qn, correct? So that feeds into the multidimensional distance formula, and that's how you're going to be calculating it, correct? So that's Euclidean distance, and this is, again, in a Cartesian coordinates is easier to understand. There's a lot of usage of Cartesian coordinate in machine learning. The other concept that I'm going to talk about is something called the taxi cab geometry. Okay. The taxi cab geometry is nothing but a Manhattan distance formula. Okay, Manhattan distance formula. The reason why it is called Manhattan distance or a taxi cab geometry is because it's in a grid format. So imagine, like in a Manhattan, you have streets and venues, right? And these streets and venues are basically in horizontal and vertical direction. Okay. Now the distance between one point to another point can be cannot be a straight line. It can either be, let's say, going from here to here, and then here to here, and here to here, here to here, here to here, here to here, and then probably here, right? So that's one way of doing it. The other way is just going straight up here and then coming down over here. So, like let's say the distance between P and a Q over here, it's not a straight line, but it's going in a grid system, correct? So the formula changes a bit, because then what you're trying to understand is that, let's say on a Cartesian coordinate format, like if you want to write this down, right? The definition of the distance between the P and the Q would be written as d of P and a Q can be written as absolute of P and Q, which is nothing but a summation of I to 1 and P of I, Q of I. Okay, so basically what you're doing is, let's say if you have P with the coordinates of P1, P2, P3 until Pn, and Q of Q1, Q2, Q of n, the distance between the two can be written using this formula. Okay, you're not doing, again, in a taxi cab situation, let's say in a two-dimensional format, it can be simply written as P1 minus Q1 absolute term, P2 minus Q2 absolute term. So that's just a simple formula in a Cartesian coordinates space. So that's why it makes it much more simpler. Now the usage of this is definitely in a grid-based system, right? So in grid-based system, this is definitely useful, because in a grid-based system or in a pixel-based system, you can actually evaluate these formulas very easily. So there shouldn't be a big problem for that, right? So that's why I think taxi cab or Manhattan distance formulas are calculated much more efficiently. Hope this gives you a good idea of what Euclidean distance and what Manhattan distance is. And we'll talk about this application in other machine learning